Okay, who did 45? I can't remember who I assigned what, but what did we get for 45? Okay, who had 45? Okay, go ahead. Yeah, 0.707, 0.707, and 1. Okay, and 707 is the same as 1 over the square root of 2. Now, IB doesn't rationalize their denominators. So 1 over the square root of 2 usually is written as this, root 2 over 2. So you'll see it like on our unit circle as that. These are the same thing. So I'm going to write it as root 2 over 2 so that it matches the unit circle. Okay, 60 degrees. Who was our 60? Hello? Okay. Yeah, 60? Okay. What'd you have? Root 3 over 2, so that would have been 0.866. And then what was the next one? 0.5, which is 1/2. Okay, and then root 3. And I don't know if we got a decimal for root 3. Say it again. Okay. Okay, 135. Okay, 150. Okay, and 240. 0.866, which is root 3 over 2. Positive or negative? Okay, good. Which is root 3. Okay, and then 315. Okay, so that's negative root 2 over 2. Okay. Root 2 over 2. Yep. And there's your chart. All right. So that's where we left off on Friday. Okay, and turn to page 10. All right, periodicity, guys. What this means is every time, periodicity means the values are going to repeat. So since there's 2 pi radians in a full revolution, 2 pi or 360 degrees, doesn't, okay, if we add integer multiples of 2 pi to the angle, then the position of P on the unit circle is unchanged. So all that means is, if we were at some point here, and I take that angle and I add 2 pi to it, I end up in the exact same place. These angles are called, so if I took this angle right here, pi, or whatever that is, I don't know how big it is, and I add 2 pi to it, it's just going to end up right back where it started. Or if I subtract 2 pi from it, it's doing that. So every 2 pi, you're going to end up in the same place. Okay, so the cosine and the sine values aren't going to change. So for example, let's say that this was at pi over 3. If I add 2 pi to pi over 3, the next one is going to have the same cosine value. It's still going to be whatever that x-coordinate is. All right? And then the same thing's true for sine. All right? So the period for sine and cosine is 2 pi. That means if you add 2 pi to an angle, the cosine value is going to repeat. All right? If I add 2 pi to the angle, the sine value is going to repeat. All right? So it says find the 4 angles that have the same sine and cosine as pi over 3. All right? So if I wanted to find 4 angles, I can just add multiples of 2 pi. Okay? So for example, if I let k equal 1, okay, then the new angle would be pi over 3 plus 2 pi. All right, rewrite 2 pi with a 3. So that would be the same as 6 pi over 3. So another angle that has the same sine and cosine would be 7 pi over 3. All right, now to get another one, go around the circle again. So I'm going to let k equal 2. So this would be pi over 3 plus 2 times pi. That's just going around the circle, another. So this is 4 pi. So if I rewrite it with pi over 3's on it, it's going to be 12 pi over 3. Any questions on why that's 12 pi, guys? Okay, so another angle would be 13 pi over 3. And so on. Okay, let k equal 3 now. So pi over 3 plus 2 times 3 times pi. So this is 6 pi. So in terms of writing it with a 3, it would be 18 pi over 3. Okay, and if I went one more, I'd have pi over 3 plus 2 times 4 times pi. That's 8 pi, which is 24 pi over 3. So that's 25 pi over 3. These are all the same. We call them coterminal angles. These are called coterminal angles. They terminate at the same place. All of these would have the exact same sine and cosine value. Okay, now tangent's different, guys. Tangent, you don't have to go all the way around for the value to repeat. Okay, so for tangent, we know that at this point, okay, at this angle, the tangent of theta right here is sine over cosine, okay, which is b over a. That right there is the tangent for that point. Okay. Well, you'll get the exact same value if you add 180 or just pi to it. Because when you do the pi down, the tangent down here, you get negative b over a. Okay? This is the tangent for that point. And these are the same. So tangent repeats every pi. So every 180 degrees, you're going to get the same tangent value. Okay? Just ignore this. This is like a, I don't know where that came from. Get rid of that. Okay? So for tangent, I just add pi every time. So if k was equal to 1, I would have pi over 3 plus pi. So that's pi over 3 plus 3 pi over 3. That's 4 pi over 3. That's going to have the same tangent value. So you're only adding pi instead of adding 2 pi. Okay. K equal 2, I would have pi, 3 pi, or pi over 3 plus 2 pi. So that's pi over 3 plus 6 pi over 3. That's 7 pi over 3. And so on. So all those four, if you were to type all these into your calculator, you'd get the same tangent. It would be the same number. All right, so these are some things that repeat with every time we do a tangent. You'll see this, the tangent graph repeat every 180 degrees. You'll see the sine and the cosine repeat every 360 degrees. All right, so like over here, one cycle of cosine looks like this. That's one cycle of cosine. And from here to here, it's 2 pi. So I could just take this, attach it right there, and then that's the next period of cosine, and so on. For sine, it's the same thing. One cycle of sine, that's 2 pi. Okay? If I just took this and copied it and attached it right there, it's just going to repeat every 2 pi. With tangent, tangent repeats every pi units. So a tangent graph kind of looks like this. And it's undefined there. So there's these little S, we call them vertical asymptotes. It doesn't touch that line. And then it's going to repeat again. So this distance right here from negative 2 pi over 2 to 2 pi over 2 is how far? Pi. That's pi units. So this is the period of tangent. Then the next pi units, it repeats. The next pi units, it repeats. Okay? All right, now, if you look at the next thing we're going to do is find some other patterns that are true with sine and cosine. Okay, so for example, if you look at this, okay, cosine values in this particular case, when do they repeat? Okay, this whole thing is going to repeat every 2 pi units. But if you look, like if you take that value right there, it repeats again right there, the y value. You see what I mean? This y value happens again right there. Okay, this y value happens again right there. Okay, this y value right there repeats right there. How far apart are those y values that repeat? What's the distance between pi over 2 and 3 pi over 2? How many degrees? 180, yeah, or pi. It's the same thing. Okay, so the cosine at pi over 2 is the same as the cosine at 3 pi over 2. Every time I add 180 degrees, I'm going to get the same thing. So let's say that the cosine here, this would be 60 degrees right here. When am I going to get another cosine that's the same as 60? Yeah, 420, but is there another time where I do get another cosine that's the same level as this? Okay, 200 and how many degrees? Okay, if you were here, well, just look here on, let's see, do we have our unit circle? Okay, look at your unit circle. It's attached to the back of your paper. Okay, let me pause this for a second. Okay, what we're doing is we're finding out this pattern right here. We're going to look at this pattern and see there's something that's true here. Okay, all right. So in the very back, you got your unit circle. All right, so there's a cosine of 60 degrees, 1/2. Okay. When do you get another cosine that's 1/2? Or when do you, let's start with sine. Let's do this one. Okay. Sine at 60 is root 3 over 2. When does that happen again? 120. See how these have the same sine values? So when that right there, how far apart are these two angles? 60. All right? And then they repeat. Okay, now, let's see, when we look at these numbers right here, using this chart, let's see what else happens with sine and cosine. Okay, so let's go right to here. Okay. All right. You got an angle that's 100 degrees. Okay, now do 180 minus 100, and you get 80 degrees. All right. If we did 120, 180 minus 120, that's 60. You with me? Okay, now for this one, since this is in radians, we're going to take pi and subtract 5 pi over 6. Okay, so pi, which would be 6 pi over 6 minus 5 pi over 6 equals 1 pi over 6. Okay? All right, now using your calculator, find what's the sine value at 180 minus 100, or 80 degrees. This one right here is the sine of 80. Okay, so if we did our calculator, okay, sine 80, let's see, you want to make sure that you're in the right mode. Make sure you're in degrees. In degrees. Okay, the sine of 80. So let's see, sine 80 is that decimal. So if we go, I'll just write 0.9848. Okay, now do the sine of 100. That was this one right here. So if I do sine 100, see they're the same answer? 0.9848. So what this is telling you guys is the sine of 100 is the same as the sine of 80. They're the same thing. Okay? All right, the sine of 120 and 60. Okay, so if I did the sine of 60, that's this value. So sine 60, okay, 0.8660. And if I did the sine of 120 right here, sine 120, they're the same thing. You're getting the same answer. Okay, sine, that's the same. So what that's telling you is the sine of 100 is the same as the sine of 60. Okay, now if you did 5 pi over 6 and pi over 6, so if we switch to rads, these are going to be the same thing. So I'm going to go mode, switch to radians. Okay, do the sine of pi over 6. That's this one. Okay, clear. So sine pi divided by 6. okay, is a half. And then if I did the sine of 5 pi over 6, okay, so the sine of 5 pi over 6, sine, okay, 5 pi divided by 6, and you get a half again. So this one's telling us the sine of pi over 6 is the same as the sine of 5 pi over 6. Okay, so if you had the sine of 150, what would it be the same as? Based on what we just saw here. 30. Okay, based on what we just saw, the sine of 150 would be the same as 30. Okay, this is, these numbers, all of these numbers are 180, take away whatever the angle is. So this would be the same as the sine of theta. Okay, what would be the same as the sine of 10? Someone else. The sine of 170. Okay, so if you just picture why that works, guys, here's 10 degrees, roughly. Okay, here's the y-coordinate for that. Right there. So over here, this is going to have the same y-coordinate. It's going to be the same height. So that angle and that angle are going to have the same y-coordinates. That's what this is right here. Okay? So whether you're in radians or not, the sine of an angle, do you remember what do you call angles that add up to 180? Complementary or supplementary? Right. So what this tells you, I'd write this down. Okay, the sine of an angle and the sine of its supplement and the sine of its supplement are equal. Okay? Okay, so tell me what happens if you go past 180? What angle would have the same sine as 330? So 330 would be about here. 330 is all the way to there. The sine of 330, what angle would be the same as that? The sine of how much? 210, right. These would be equal. How these two numbers are related? Okay. Well, there's a couple ways you could do it. All right. If you look at okay, there's 330, right? How big is this little angle here? 30. So it's 30 degrees below that line. Well, what angle would be 30 degrees below this marker? Yeah. Right? And then, okay, you with me now? Yeah. So it has to do, these little purple angles have names. They're called reference angles. So those two would be the same. It's just like this one when I did this earlier. If I said that was 10 degrees, that would be the same as 10 degrees above here, which is 170. So 10 degrees and 170 have the same y-coordinate. 210 and 330 have the same y-coordinate. All right? Okay, now, is it true for cosine? Is the cosine of an angle and the cosine of its supplement equal? Well, let's see. So this would be 100. This would be 100. This would be 110. And this would be 2 pi over 3. Do you guys see how I'm getting those numbers? Okay, so if I did the cosine of 100 and I did the cosine of 80, how do those compare? Now, even before you do it, you can think, if this is 80 and this angle is 100, how are the cosines going to compare? This is one cosine right there. This is the other cosine right here. Are they going to be the same? No. What are they going to be? Right. They're going to be opposites. So when we type these in, we should get opposite values. So if I do the cosine of 100, okay, cosine 100, and compare it to the cosine of 80, wait a minute, they're not even the same. Something's not right. Did I use... Oh, what? Yep, classic mistake. Okay, cosine 100, okay, cosine 80, and we can see they're opposites of each other, okay? So this was negative 0.173, and this was positive 0.173, okay? So when this part right here, this is going to equal the opposite of cosine. So if we were going to write a rule for that, we would say the sine or the cosine of an angle and the cosine of its supplement are opposites. How does opposite? I'm missing a letter, aren't I? Does opposite end with a T? An E, I mean? Yeah. God bless. Okay, so the cosine of an angle and the cosine of its supplement are opposites. The sine of an angle and the sine of its supplement are equal. Okay, So what angle would have the same sine value as pi over 3? Yeah, it's supplement, okay? Okay, so this would be pi, the sine of pi over 3 is equal to the sine of pi minus pi over 3. This is the angle, this is its supplement, and its supplement, this would be 3 pi over 3 minus pi over 3, which is the sine of 2 pi over 3. Okay, so the answer to this one would be 2 pi over 3. All right, what angle would be the opposite of the cosine of 40? Yep. So the opposite of the cosine of 40 would equal the cosine of 140. The negative of the cosine of 40 equals the cosine of 140. Okay, what's the sine value of 115 if the sine of 65 is 0.9063 without a calculator? Yep. These are supplements. So the signs are the same. So the sine of 115 would also equal 9063. Okay, and then the cosine of 132 would be the opposite of the sine of 48. Cosine of supplements are opposite. So that's using that value. And we would have seen that had we just didn't fill out the rest of this. Okay, and that takes us through C. Cool. All right, so for tonight, folks, if you would please do okay, 8C, 1B, 2 through 9, and then, let's see, we did these 4 questions on the question bank. Okay, and did I give you guys copies of the question bank? Or I think I posted them. Let's see.